Let's talk about subsequent tabs: part, cutting, dwell, and machine elements. Here in those tabs, the main variables describing our part, machining process, and some elements of machine configuration are grouped. Let's start with Part tab. Here we have values concerning main dimensions of our part. To put here values concerning our part, we have to refer to its drawing. The first parameter is bar diameter. So let's look into the drawing, and the biggest external diameter here, this is 10 millimeter. So we can enter as bar diameter 12. Next one is part length. You see that we should enter here the final length taken from the drawing. In our case, this is 31. And next, this is part pickoff length. You see here that this is the distance counting from the face of our part to the position how far should move back spindle for pickoff. To determine this value, first we have discuss where we would like to start machining of our part, from this side or this side. Here you see the external thread, and of course we don't want to make pickoff on this thread. So the other possibility is to pick off on diameter 9, and then back spindle can move to this position. So we can enter as pickoff length 16.5. The next parameter, part feeding excess, needs some words of comment. First, this is the principle that we keep here value 0 until TISIS will report the error of over travel in Z1 axis. Then it will be necessary to put here positive value. So what could be the situation which demands here non-zero value? Please look into this drawing. Here, this is our cutoff tool, and this is rotating transversal tool. This is our guide bush and main spindle. And taking into account the length of our part and the width of our cutoff tool, we can say that distance needed for machining of our part, this is this length. Please imagine the situation that we would like, with this rotating tool, to drill transversal hole at this position. You see that we have no possibility to withdraw a bar enough to reach with this hole position this drilling tool. It could be collision between guide bush and main spindle, as you see. But of course, we will not have collision on a machine because the error of over travel in Z1 axis will be displayed, the same as in TISIS. So how to solve this problem? In this drawing, we see that we can give longer distance of a bar for machining of our part. And then, as you see, it is possible to reach with this drilling tool a given position of a hole. This additionally given distance of a bar, this is our parameter D, part feeding excess. And this value, as shown in the drawing, will be entered here. It is always positive value. The other situation when would be necessary to give the additional length, part feeding excess, is when we would like to machine on a position longer than part length. And what about the next parameters? Here As you see, this is the additional length given for facing made in main spindle. I could say, in other words, in main operation. And the next parameter, by analogy, additional length to make facing in back spindle, or we can also say back operation. The rest of parameters doesn't concern our case, so we will change here nothing. Let's open the next tab, Cutting, and here variables concerning machining process are grouped. On the first position, we have number of a cutoff tool. This tool is always defined in model by Tornos. When we look into the picture of our machine, you see that cutoff tool always is assembled here on this first position. And this number is the number of this position, so we keep it without any change. The second parameter, width of our cutoff tool, this is 2 mm and this is correct. Next one, angle of the insert of a cutoff tool, here we should put 20. And let's move to the subsequent parameter, spindle speed mode. You see that we can make machining in G97 mode, it means constant rotation speed, or G96, constant cutting speed. We can select between them. And of course, it doesn't mean that this selection is valid in the whole program. In this form here, it concerns only initial cutoff, I mean cutting of a tip of a bar made at the beginning of a program, and also cutting a tip of a bar after loading of a new bar. So for instance, let us select G96. And next parameter, spindle speed, this value should be given in meter per minute, so of course it cannot be 5000, we have to change it. Can be 150. If we work with mode G96 active, it means with constant cutting speed, we should refer to the parameter I, spindle speed limit. You know that during facing or cutoff, when we approach to the center of a bar, rotation speed increases. We don't want to have a big increase of rotation speed, like for instance to the maximum value. That is why here we should enter the limit of this rotation speed. The parameter above, F, determines feed rate during cutoff of a tip of a bar, and some additional comment concerning the last parameter, increment of chip breaking. You see on this drawing that we can make cutoff of a tip of a bar in interrupted movement. It means that a tool moves by given distance, for instance 1 millimeter, and after it stops for a time given in second in the next parameter K. This stop is done to break a chip. And the last one, it is also possible for a tool to retract a little. We will machine a brass bar. That is why it isn't necessary in our case to make initial cutoff with chip breaking. So we remove those parameters and also we'll select mode constant rotation speed. In next parameter, let us return to that value 5000. I have added that this chip breaking, this is in this form here, it concerns only initial cutoff. But of course, the range of application of this possibility, of this facility, is much wider. We can use it for turning, drilling, milling. But this is the option. This is the ACB paid option. If you would like to use it on your machine, you should direct to your Tornos representative and buy it. These are all parameters in this form. Let us discuss now the next tab, Dwell. In these forms, delays after opening and closing of collet in main spindle are defined, as well as after opening and closing collet in back spindle. There is also the delay after stopping bar feeder to push. And the last one, delay before closing collet in main spindle when a bar for the next part is fed. All those values are optimized by Tornos, so there is no need for us to change it. If you would like to experiment with those values, you can do it on your own risk. And what about the last one, machine elements? Here we make selections concerning main configuration of a machine. First, this is guide bush type. You see that we can work with motorized guide bush or without guide bush or non-standard. In our case, we stay with motorized guide bush. The second parameter, type of bar loader, we keep it as it is. And the same with the last parameter, we stay with standard method of ejecting of a part.